Science is changing. We all know the traditional model in which the same scientist both does an experiment and explains why the result was the way it was. And Galileo is the best known example that he went up to the top of the Leaning Tower of Pisa himself and dropped off a heavy thing and a light thing to see if they would fall at the same speed. But there's also another model, and that's where one group collects the data and other people interpret it. And an early example of that was that Kepler got his laws of planetary motion by looking at the observations made by Tycho Brahe. That second model, in which we separate data collection and data understanding, is becoming more and more common. And the late Jim Gray referred to it as the fourth paradigm. It's also called data-intensive science. By separating the two tasks, you permit people to be more specialized, you permit greater numbers of people to participate, and you accelerate science because the data is collected ahead of time. On the screen is an example of one of the big databases, the Sloan Digital Sky Survey, which photographs the entire sky and has currently got about 140 terabytes of sky images stored up. And what this means to an astronomer is if they have a question about something in the sky that affects that they want to use for their theory, they don't have to wait for their 2 weeks at Mauna Kea or Kitt Peak. They can just go to the survey and see what the data is. This particular picture is in Orion. Another large database is the Census of Marine Life. This is trying to identify everything in the ocean at 25 specific places around the world. And that's being used by ecologists, by oceanographers, by zoologists to keep track of how are things changing in the ocean over time. This one is actually an example at Rutgers. There is something called the Protein Data Bank, which is run by Helen Berman about a mile away from here on Bush campus. And everyone who measures the structure of a protein molecule for several decades has had to deposit it in the Protein Data Bank so that other biochemists can look at it and can use it in their work. They have a molecule of the month on their website, and this is lactate dehydrogenase. The last example I'll show is the IRIS seismic database. This is run out of the University of Washington, and it keeps track of all earthquakes of all sizes around the world. And as we unfortunately now know, as you look at this, the earthquakes occur around the Pacific Rim, particularly near Japan and Indonesia. So this is the new model in which the data is collected and then later it's analyzed. But now you ask, so if we have these huge data banks, 100 terabytes of seismic data, 140 terabytes of astronomy, how do they get used? Well, people compare them. Here, for example, if someone looked at the sky in the visible, the Sloan Sky Survey on the right, and in the infrared, the 2-micron all-sky survey, 2MASS on the left, and they identified a brown dwarf by looking for something that had the right characteristics in both wavelengths. So this is an example of discovery from data-intensive science. How do you find anything in this data? Well, one way is what is called crowdsourcing. Chris Lintott has a project called Galaxy Zoo, in which amateur astronomers all over the world look at pictures of galaxies and say, this one is a spiral galaxy, that one is a globular cluster, and so on. And on the screen now is their most interesting discovery so far. The woman is Hanne van Arkel, a Dutch school teacher who was one of their volunteers. And on the right is this strange thing she found, which is known as Hanne's Voorwerp, and nobody knows what it is. It's sort of Kermit the Frog in space, but the astronomers are still trying to find the explanation. And so this is a discovery which wouldn't have been made if we hadn't had a lot of people looking at the sky. Here's another pair of examples. These are from Earth observation. The man, Dave Bertelsen, has done the same hike every day for 20 years. And he writes down what's in bloom, what animals and plants he sees, and that's being used to study climate change. Similarly, Amy McDonald has sent in hundreds of observations of birds. which are being again used to see whether birds are showing up in different places at different times to study the effect of climate change on bird migration. And what I look forward to is that this ability to have more ordinary people involved in science will both increase public interest in science, increase public understanding, and will help encourage more school children to go into science as a career.